come close to Jupiter, within 54 million kilometers from Jupiter, and there is a spacecraft orbiting Jupiter called Juno that we hope that NASA will use to learn more about it. And altogether, it's very exciting because we've never thought about the potential implications of.
Harvard scientists just dropped the new 3-Eye Atlas image, and what's next could change everything. Something is barreling through our solar system right now, and it's not behaving like anything we've ever seen before. It has a tail pointing backward, it's flying in the plane of the planets, and in just 7 days, it will reach a point in space where, if it's what some scientists think it might be, it could deploy something toward Earth. This isn't science fiction. This is happening right now. And the world's leading astronomers are watching the skies with a level of urgency we haven't seen since the first interstellar visitor arrived in 2017. But this time, the stakes are different. This time, the object is bigger, much bigger, and its trajectory is almost too perfect to be natural. The object is called 3-Eye Atlas. It was discovered earlier this year as it crossed into our solar system from interstellar space. At first, astronomers cataloged it as just another comet, a wanderer from the cosmic deep passing through our neighborhood on its way to nowhere in particular. But as more data came in, something became clear. This wasn't just another comet, it was an anomaly. NASA's Hubble Space Telescope captured the first detailed images of 3-Eye Atlas as it moved inward toward the Sun. What those images revealed was startling. The object had a tail, yes, but not the kind you'd expect. Most comets have tails that stream behind them, blown backward by the solar wind as they approach the Sun. But 3-Eye Atlas had something else: a forward-facing tail, an anti-tail. A structure that defied the basic physics of how comets are supposed to behave. Then came the size. Initial calculations suggested 3-Eye Atlas was at least 1,000 times more massive than the previous interstellar objects we'd observed. Some estimates put it at 1,000,000 times larger. That's not just unusual, that's unprecedented. For context, Oumuamua, the first confirmed interstellar visitor, was small, cigar-shaped, and moved through our system without much fanfare. 3-Eye Atlas is different. It's enormous. And it's not just passing by, it's coming close, very close.
Finding an object that big that could be something other than a rock, an icy rock. Just imagine that it was a technological object that selected this orbit to be aligned with the planets around the sun for a reason.
Professor Avi Loeb, head of the Galileo Project and founding director of Harvard's Black Hole Initiative, has been tracking 3-Eye Atlas more closely than perhaps anyone else on Earth. He's written 2 scientific papers attempting to explain the object's strange behavior, specifically the anti-tail that seems to defy conventional comet physics. But even he admits the explanations aren't simple. In fact, they're not entirely satisfying. The anti-tail, Loeb explains, could have a natural origin. Dust particles ejected from the comet might be oriented in such a way that they create an optical illusion, making it appear as though the tail is pointing forward. But there's a problem with that theory. We don't know if there's dust around this object at all. And even if there is, the mechanics required to create such a pronounced forward-facing structure are not straightforward. It's possible, yes, but it's not easy to explain. What makes 3-Eye Atlas even more puzzling is its trajectory. Unlike most comets, which enter the solar system from random angles and directions, 3-Eye Atlas is traveling almost perfectly within the plane of the planets, the ecliptic plane, the same flat disk where Earth, Mars, Venus, and Jupiter orbit the Sun. And it's not just passing through, it's coming close to 3 of those planets: Mars, Venus, Jupiter. The odds of an interstellar object randomly entering our solar system and aligning so precisely with the planetary plane are extraordinarily low. It's not impossible, but it raises a question that astronomers can't ignore. Does this object have a purpose? Loeb is careful with his words. He's a scientist, and he knows the burden of proof required to make extraordinary claims. But he's also willing to ask the questions others won't. In a recent interview, he described the coming weeks as a make-or-break moment for understanding what 3I Atlas truly is. On October 29th, just 7 days from now, the object will reach its closest point to the Sun. It will be 203 million kilometers away. That might sound far, but in astronomical terms, it's practically touching the Sun's doorstep. And more importantly, it's the perfect position for a gravitational maneuver. If 3I Atlas is simply a natural comet, it will continue on its current path, swinging around the Sun and heading back out into interstellar space. But if it's something else, something technological, this is the moment when it would act. An engine could fire, a thrust could be applied. The object could gain kinetic energy and accelerate forward, or it could brake, slowing itself down. And if it slows down, it could release smaller objects, many probes, scouts, devices designed to navigate toward the planets while the main object continues its journey. This isn't wild speculation. It's a tactical assessment based on orbital mechanics. If you were designing a mission to explore multiple planets in a solar system, you would do exactly what 3I Atlas is doing. You would enter along the plane of the planets. You would time your arrival to pass close to multiple targets. And you would use the Sun's gravity to adjust your trajectory and deploy secondary craft. It's efficient, it's elegant, and it's exactly what 3I Atlas is positioned to do.
Designed by some intelligence, and we are not prepared for such a visit. And perhaps the wake-up call from 3I Atlas, this object, will alert us to be more aware of the potential risks. And I wrote actually.
But here's the problem. We can't see it right now. As 3I Atlas approaches the Sun, it's moving into what astronomers call Earth's blind spot. The glare from the Sun makes it impossible for Earth-based telescopes to observe the object during its closest approach. We're flying blind. And the timing couldn't be worse. Just as 3I Atlas reaches the most critical point in its journey, just as it arrives at the exact location where any intelligent system would make its move, we lose visual contact. Adding to the frustration, NASA's high-resolution images from the Mars Reconnaissance Orbiter, which should provide 3 times better pixel resolution than Hubble, have not been released. The government shutdown has delayed access to that data. The images exist, they were captured, but scientists don't have them yet. And those images could be the key to understanding whether 3I Atlas is outgassing like a normal comet, whether it's ejecting material in unusual patterns, or whether it's doing something else entirely. The international astronomical community is not sitting idle. Yesterday, the International Asteroid Warning Network announced a coordinated global observation campaign. Telescopes from around the world will be synchronized to track 3I Atlas as closely as possible, gathering data on its motion, its composition, and any changes in its behavior. The goal is simple: collect as much information as possible before, during, and after the Sun flyby. Because if something unusual happens, if there's any deviation from a natural trajectory, we need to know immediately. So what are the possibilities? Let's start with the simplest explanation. 3I Atlas is a comet. A very large, very unusual comet, but a comet nonetheless. The anti-tail is an optical effect caused by dust grains aligning in unexpected ways. The trajectory through the planetary plane is a coincidence, statistically unlikely but not impossible. The massive size is simply a reflection of how little we know about interstellar objects. We've only observed a handful of them, so our sample size is too small to determine what's normal and what's not. This explanation is plausible. It fits within the framework of known physics. It doesn't require us to rewrite the laws of nature or invoke exotic hypotheses, but it also doesn't explain everything. It doesn't explain why 3I Atlas is so much larger than previous interstellar visitors. It doesn't explain the precision of its trajectory. And it doesn't explain the forward-facing tail, which remains, at best, poorly understood. Then there's the alternative. The hypothesis that Avi Loeb and a growing number of scientists are willing to entertain. What if 3I Atlas isn't entirely natural? What if it's a probe, a craft, or a hybrid object, part natural and part engineered? What if an advanced civilization harvested a comet or asteroid, hollowed it out, equipped it with propulsion or sensors, and sent it on a journey through the galaxy? Such a craft would look almost exactly like 3I Atlas. It would have the mass of a natural object. It would have ice and rock on its surface, outgassing as it approaches a star. But underneath, it could have a purpose. This isn't fantasy, it's a legitimate scientific hypothesis. In fact, humanity has already considered similar concepts. The idea of using natural objects as camouflage or substrate for long-duration space missions has been discussed in theoretical studies. If you wanted to travel between star systems and minimize detection, wrapping your technology inside a comet would be an effective strategy. It would shield your systems from radiation, it would provide raw materials, and it would make your craft nearly indistinguishable from background objects.
Actually, a white paper to the United Nations that I sent last week with the hope that they will establish an international committee that would analyze future data on other interstellar objects like 3I Atlas that we will get in the...
If 3I Atlas is technological, the implications are staggering. It would mean we are not alone. It would mean an intelligence exists, or existed, somewhere in the galaxy with the capability to engineer interstellar missions. And it would mean they chose our solar system as a destination. Whether that choice was deliberate or coincidental, we don't know. But the fact that 3I Atlas is traveling within the plane of the planets suggests a level of intentionality that's hard to ignore. Loeb emphasizes that we must observe, we must collect data, we must be rigorous and methodical. Science doesn't advance through assumptions or wishful thinking. It advances through evidence. And right now, we need more evidence. That's why the Galileo project is monitoring the sky with 3 dedicated observatories. That's why Loeb has asked his research team to check for unusual activity around Earth, Mars, and the trajectory of 3I Atlas itself. That's why the Juno spacecraft, currently orbiting Jupiter, will use its radio antenna to scan for emissions from 3I Atlas as it approaches the giant planet. If 3I Atlas emits any radio signals, even faint ones, it would be a technological signature. Natural objects don't broadcast radio waves in structured patterns. Only technology does that. And if Juno detects something, if there's even a hint of an artificial signal, the conversation around 3I Atlas will change overnight. It won't be a debate anymore. It will be confirmation. For now, we wait. 3I Atlas is hidden behind the sun, moving through the blind spot, approaching the moment of truth. On October 29th, it will reach perihelion, the closest point to the sun, and then slowly, it will emerge on the other side. By December 19th, 1 week before Christmas, it will make its closest approach to Earth. That will be our best opportunity to observe it from the ground, our best chance to capture high-resolution images, to analyze its surface, to measure its composition, and to determine once and for all whether this is just a rock from the stars or something far more profound. The internet is already flooded with speculation. Some claim 3I Atlas has already changed course. Others insist it's part of a larger fleet. The misinformation is rampant, and it's making it harder for the scientific community to communicate clearly. But the truth is, we don't know yet. We won't know until we have the data, and the data is coming. The Galileo Reconnaissance Orbiter images will eventually be released. The Global Observation Campaign will deliver its findings. Juno will complete its scans, and Earth-based telescopes will capture the object as it passes by in December. What will we see? Will 3I Atlas continue on its natural path, confirming it as an unusually large comet and nothing more? Or will it do something unexpected? Will it adjust its trajectory? Will it release smaller objects? Will it emit a signal? These are the questions that will be answered in the coming weeks and months, and the answers will reshape how we understand our place in the universe. This is not just about one object. It's about a shift in perspective. For centuries, we've looked at the sky and wondered if we're alone. We've built radio telescopes to listen for signals. We've sent probes to the edges of our solar system. We've scanned distant stars for signs of planets that could harbor life. But we've always assumed that if we ever encountered evidence of alien intelligence, it would be obvious. A radio transmission, a megastructure, an unmistakable sign. But what if we'd been looking for the wrong thing? What if alien technology doesn't announce itself? What if it travels quietly, hidden inside natural objects, indistinguishable from the cosmic background until it's already here? Oumuamua raised that question in 2017. 3I Atlas is forcing us to ask it again. And this time, the object is bigger, stranger, and far more difficult to explain. Avi Loeb has dedicated his career to asking uncomfortable questions. He's willing to consider possibilities that others dismiss, not because he's reckless, but because he understands that science advances by testing hypotheses, even unpopular ones. He's written papers on 3I Atlas, he's organized observation campaigns, he's coordinated with space agencies and research institutions around the world. And he's doing it all because he believes we owe it to ourselves to know the truth, whatever that truth turns out to be. We are living through a moment of cosmic uncertainty. An object from beyond our solar system is passing through our neighborhood, and it's not behaving the way we expect. It's too big, its trajectory is too precise, its tail is pointing the wrong way. And in 7 days, it will reach a position where, if it's technological, it could make its move. This is not science fiction. This is not speculation run wild. This is real. This is happening. And the world's best scientists are watching, calculating, and preparing for whatever comes next. On October 29th, 3I Atlas will swing around the Sun. By December 19th, it will pass close to Earth, and as it approaches Jupiter, Juno will be listening. We will have our answers soon. We will know if this is a comet, a cosmic coincidence, or something that challenges everything we thought we knew about the universe. The beauty of science is that it doesn't rely on belief, it relies on evidence, and the evidence is coming. Soon we will know if we are witnessing a natural wonder or something far beyond human imagination. Soon we will know if the universe sent us a rock or a message. And when that moment arrives, when the data is in and the analysis is complete, we will look back at this time and realize we were standing on the edge of discovery. We just didn't know which side we would fall on. The countdown has begun. The telescopes are ready. The question has been asked. Now, we wait for the answer. If you want to stay updated on what happens when 3I Atlas emerges from behind the Sun on October 29th, and whether it reveals itself as a natural comet or something far more extraordinary, make sure to subscribe and hit the notification bell. We'll be covering every new image, every data release, and every discovery as it happens. The answer is coming soon, and you don't want to miss it. Subscribe now, and let's uncover this mystery together.